Python for software. But aside, using Python for everything I've mentioned, I've also, for one reason or the other, work on different other software projects, front-end with Angular, mobile app with Flutter, and the rest. But my core specialization is Python. And I believe this is a Python class too, and I welcome us officially to this class. But we won't just be jumping straight into Python. We try to set some background and then we move from there. So normally I would have loved to start with our usual trying to get us ready for the industry, but I'll be taking that towards the end since I'll be with us for a while. So I can always take that particular part towards the end of the course. So it's good meeting everyone. Please, it's going to be a software engineering course, and I like to be very sincere. Software engineering is not difficult, but it is not easy. So that's my way of putting the facts right. It is not difficult, but it is not easy. And as a matter of fact, I like to put it this way: if it is very easy, then it is not valuable. It is always valuable because it is not easy. So look at it this way: if what you are doing or whatever you are learning to do just require me telling someone, "Hi, Joel, please read this article and you start doing these things for us from tomorrow," then I won't see a reason to go and recruit maybe 2 or 3 people that would be like, that we're going to bring on team, and then they will majorly be doing these things. And they will start billing me for premium. Why? Because it's easy. I can easily tell Joel to read it in 5 minutes and do it. So software engineering is very valuable because it has some learning curve. It requires some level of personal commitment for you to actually get to the right level. And that's what I will be loving everyone to bring to this call: personal commitment. Now, let's delve into this. I know on this call, we have people that are new to software engineering, and we have people that have maybe completed a mobile app course or an Angular course before now, people on full stack software. I know we have people on full stack that are just starting, but people on full stack that have completed their first set of the program, maybe a Flutter or an Angular. It might not, you might not be very new to the software engineering field, and of course, you'll be able to adjust a lot of things. But irrespective of whether you are new, you have no previous experience, no previous knowledge, no need to panic. Everything you would need to work would be given to you on this training. So I'll proceed now. Before I proceed, okay. Now, software engineering generally, we all know what software is, but I'm just going to give us practical example. Software is not far away from us. We are currently on a live call trying to do a meeting, right? This meeting we are currently doing is powered by software. It is because there's a software called Zoom that we cannot share the link to say, please join this call, and everyone join the call. That's a software. For people that have enrolled for this course, maybe through our website or similar sources, you actually went to a website, maybe a techoga.com, and you click on a particular course and complete the entire process. You are interacting with a software. For people that maybe they get to know about Techoga the first time via a Facebook ad or a TikTok or an Instagram, you're actually on Facebook, on Instagram. As at the time we were doing that, Facebook, Instagram are examples of software. So that is to say, software powers the world. And that's why it's one of the fastest growing career we have today. Irrespective of any other field that is moving, whether cybersecurity, whether AI, even AI and the rest, all of them still have their foundation laid on the software. So for example, a ChatGPT is impossible if there is no software where you will go to interact with it. As a matter of fact, ChatGPT is primarily, let's say, an API, a backend API. And they only just build an interface to it for general users that they want an interface to interact with the software. But if you're also a developer, you can actually integrate ChatGPT into your systems or software using just the backend API that they supply. So in reality, even AI lands on software, whether you're using DeepSeek, whether you're using ChatGPT, Meta, and the rest. So in everyday life, we use software. On your phone, you might likely have transferred money today to someone, log into your Access Bank app, your GT Bank app, that is a software. So software is anything that you can access via your phone or any of your device YouTube is a software. And when we say software engineering, it's actually the process of building all these things that I've highlighted so far. So the expectation would be people on this call are people that are equipped to build systems. And I'm going to clarify this more. Please, if you have any question anytime, as rule of engagement, feel free to raise your hands. You can use the raise emoji. And then, of course, I will let you speak. If I'm not noticing that, you can also unmute and speak up. I'll take a pause for you. Or I also always check out for messages in the chat room. So I will always ensure I check that out and answer your question. And also, I would like to mention that I like my class to always be interactive. So once in a while, I may ask you questions, of course. If you also feel something is not clear, please feel free to let me know. Sometimes I may also be tempted to be moving a little fast. Please, you don't have to cope with it. You just have to tell me I'm moving too fast. Sometimes I've tried to teach a lot of different audience, local and international audience, and sometimes I've had international audience that just prefer you move at a particular speed. So, they're able to catch up faster using that approach. And I've also, have people, of course, for example, in Nigeria, our way of administrating things that we speak a little more slowly, trying to grab these things topic by topic. And I try to, I'm trying to just adjust myself to strike a balance. But if at any point in time I'm moving too slow for you, please feel free to stop me and let me know. If I'm moving too fast for you, also feel free to stop me and let me know so I can adjust appropriately. Or if I'm not loud enough, maybe my pitch is too high, whatever scenario you actually observe, feel free to let me know. Now, software, we've talked about software, right? Now, software now has different types or different segments. When you see these softwares I've mentioned, YouTube, Facebook, Twitter, Access Bank app, the Zoom meeting we are currently using, and the rest, all of them have systems, right? There are systems powering them. Yeah, so I guess I missed something on this, right? I wanted to just have it separately before then I changed my mind. So we have stuff like Flutter, React Native, and several other ones, Java, and several other languages that can be used for this. Now, so we have three major segments, or let's say two, and we have two major segments of software, majorly. The first one is called the front-end software. Now, front-end of a software is what we see every day. It's what we interact with. So when we are currently on a Zoom call now, you can see a join button, a pause button, having a pause icon, what's it called? You can see a lot of things currently, physically. That's a front end. From the word front, the front part of software. When you go to techoga.com, you go to gtbank.com, those things you can see are front-end technologies. Now, that front end can be divided into two, majorly. The front end can be a web application. So majorly, just like today, there are two major channels through which we interact with systems. There are many channels. So don't let me start with two major channels. There are many channels through which we interact with software. But we only have two that is most popular today. And many of us are on this call, maybe we are using just two. One, we have web. Any application you go to a browser to access is web. You go to your web, you open a Chrome on your phone, and you try to go to zoom.com, you want to download Zoom. That zoom.com is a website. You go to accessbank.com, whether it's your internet banking, it's a web application. As far as you need to open a browser on your device to access it, it is called a web application. I guess it's ready. So let me change my location so as to avoid background noise. Just a second. Okay. So like I was saying, those are front ends, right? You go to website, you access them, that's a web application. The second sub-component of front end, you can access it on mobile apps. You go to your Play Store, Google Play Store, you download a new application, that's a mobile app. You go to Apple App Store, you download the mobile application, that's a software, a front end. You go to, majorly, you go to your, what's it called, Windows, Microsoft Store, you download the application, that's a desktop application, the Windows category, because it's on Windows. So we call them Windows desktop application. So for example, you are currently on this call. Some of us are on our laptops to join this call. So you are using the Zoom application on your laptop. It simply means you are using an example of a Zoom Windows, of a Windows desktop application. Now you leave that and you go to, maybe you're on Mac and you go to App Store to download this. It's still a Windows app, it's still a desktop application, only that it's now a Mac desktop application or an Apple desktop application, whichever one, but they are all desktop application as well as they run on your laptop. Now, we also have other not so popular front ends. Your smartwatch can have an application. It can also be a mobile application, interestingly, but whatever you can access, those things that you see physically, that the user would see, sometimes we call them the user interface, the user experience, what they interact with. They are front-end applications. Now, there are different programming languages that are used to create this. React, Angular, Flutter, React Native, Java, and the rest. So all these technologies I've mentioned, they are used in either building web applications, desktop applications, mobile app applications, or cross-platform applications. Now, all these things I've mentioned, when you build with this technology, there is a limitation. The limitation is everything is just graphics. It doesn't have any capability. A Zoom front end without a back end is just a graphics interface. You can't sign up and come back and sign in tomorrow. You can't do a meeting like we are doing a meeting. You can click a button to say, open meeting, go to meeting page, but you're not seeing anybody join that call. Because it's just like someone designed a moving graphic. See it that way. A graphics that has the capability to move if I click buttons. And that's not all to software. So every software you see out there, Facebook, Instagram, and the rest, they have what is called a back end. Back end is what handles the major logic of every software we've mentioned so far. When you go to your Access Bank app and you enter your username and your password to log in, you click on login. The only reason that login button is able to work and create a result is because there's a backend that is ready to receive that information you've entered, process it using its logic, confirm if you have an account. If you don't have an account, it will tell you incorrect username and password. If you have an account, it will tell you, it will return some token or whatever, and the front end can take you to the next page and probably get your account details, how much you have in your account, and the rest. Because there's a backend that handles the logic. Now, I'm still coming back there. Let's look at it this way. Look at it this way. Someone has let me show you an example of a backend. I think that'll be better. A Python Django backend. I'm going to run one. I guess at this point, I will share my entire screen. I'll come back to my theory. I want to make this as interactive as possible. Close. Sorry, I have a lot of things open on my laptop, databases and softwares, and I have to make sure they are off. Okay, live is closed. Just a second, don't save. Okay. I'm meant to share my entire screen so that I'm not sharing and stopping, switching several times. So I'm trying to just play my desktop and it'll be easier for me to share desktop. Okay, share entire screen. Let me know if you can see my screen. Well, let me reshare again. It's looking like I'm sharing just my PowerPoint screen. Can you see my entire screen? Let me know if you can see. Let me navigate something. Let me know if, can you see my screen? Can you see like something like a VS Code?
No, we can't.
Okay, so what's the issue? Yeah, you should be able to. You can't see anything on my screen. Let me reshare. Okay, I guess this guy is stopping it. Well, I get the problem now. I need to stop sharing that for this to work. How about now? Can you see any moving parts?
Yes, we can see your screen now.
Okay, all right, good. Thank you. Now, just wanted to test, just wanted to show us an example of a backend.
Yes, I can see your entire screen, but it's not covering the whole space.
How about now? Maybe I just stop video sharing. Without the block all. Can the video share? Yeah.
We can see your screen.
All right, thank you. Okay, so I'm going to pick one endpoint to use as example. I just want secure one. I'll do the backend class. Let's make it realistic. Okay, I don't even need to do that. Well, I need an endpoint so that you can get you need to do some practical so that you have a strong background in this. So what's happening? This is the endpoint. How am I adding elements? Okay. This tenant does not exist. Oh, I will need one tenant to demonstrate this. Let me look for something else. Sorry. I've deleted some tenants that I have there.
Hello, Mr. Femi Bamiji.
Yes, I'm with you.
Please, as a backend developer, please can a backend developer be a roadmap to a cloud computing?
Be a roadmap, what?
With cloud computing.
Your network, maybe it's your network. I didn't hear that part very well.
Okay.
Can
Being a backend developer be a good roadmap to a cloud computing?
Yes, I'll come back to that.
All right.
I'll make sure I talk about that today.
Thank you.
Yeah. Okay, I have an endpoint, but I don't have any block. No, let's start creating something here. Trying to see if there's anyone I can even have any data to show. Okay, I think I have where I can show. Okay, so let me just use this. Now I just created this afresh, so I may not have much. Just wanted something to return one data. API/users. I've removed that. Oh, sorry, I have a that will not work. I need an endpoint. I didn't think of this before, but I need one. If someone trying to speak, I can see your voice is breaking. Although all these endpoints are working, only that I've not created data yet, and I don't want to start creating data now. That would take some time. Okay, but I'll come back to explain whatever I want to explain here. Do I have a block? No, I won't have any data there too. Okay, what I wanted to show you is that endpoints are like URL endpoints, like this, right? Let me go to one website, jumia.com. I think that would be a good, or let me pick maybe not something that have that big data. Was any example data? Jumia.com. I think Gmail was built using. Let me use no, not login. Trying to think of a website that has listing that's not e-commerce. Maybe GSC. Okay. I think maybe I can see something like this example. We see more complex examples move on. Now, behind every software you see out there, that's where I'm going. Whether mobile, whether web. See, all these things you can see here now, they are just like, how do I put it now? They are just graphics, right? Of course, I can click from one page to another page, it's still graphics. When you come on Facebook and you enter your, so I think I had Facebook even open earlier. Let's see how Facebook does it. Sometimes, no, there are front end that can hide this very well. Let me remove it. Let me put some random value and some random password. Let me clear network login. The email address enter is incorrect. I want to see if I can quickly just see where this went out. But the way this works, the point I'm trying to make is this. When you come on Facebook and you enter your username and your password, what happens here is there's a backend that can process this information. And what will simply happen is that Facebook front end, whether mobile or web, we take those two information you've entered, send it to an endpoint that a backend software engineer has provided. A software backend engineer receives it in his own software, checks it against the database. Is this user previously signed up? If not, it will return a response, invalid account. When it returns that response, the front-end engineer, maybe a mobile app or a web, will then decide how to display it. If he likes, he can display it on top. If he likes, he can make it a pop-up. If he likes, he can just display it any way he wants. Facebook is displaying here for us. The front-end engineer decides where to display it. But whatever the error is the back-end engineer that supplies it. So back-end software engineering, it's like what powers every front-end you see out there. It's the one that interacts with the databases. And that is why sometimes it is more critical, more complex. And whenever you hear hackers is hacking a platform, 98% of the time, what they are hacking is the backend. If you hack my front end, you will not achieve anything actually. What will you achieve by hacking my front end? You can't even hack front end. Because even when you DDoS, when you try to DDoS, sending a lot of response, a lot of traffic to my site at the same time to bring it down. Of course, aside the fact that you might be wasting my cloud resources or exhaust my backend API request or something. So majorly, you don't even hack front end. What we hack is backend. Your databases, your access credentials, user password, and all the rest, they are security breaches of a backend software. And that's why the work of a backend engineer is a little bit more difficult than a front-end engineer. Both of them are very lucrative. They are very lucrative career. But they have different areas. Now, a front-end engineer, his headache is always on user experience. Imagine if I come to Facebook now, the olden days Facebook, and I have to scroll. You scroll, it will still open big on your phone, and you have to scroll to the right, like, those experience. That was during the experience. Now, is the front-end engineer work now to ensure that, the site I'm building, if they access it on mobile, they can view it. If they access on desktop, they can view it. And wherever they access it, they can still view whatever is there. Now, that's the work of a front-end engineer. Back-end engineer is the one that will then decide this information coming, when it arrives, am I sure? Let me just do something briefly. Let me use our website, for example. And let me just refresh something. Let me look for one data, maybe our blog. The responses. Now, you can see when I refresh this page, right? You could see a lot of findings on this page. You could feel like, oh, maybe, so let's say I make this a little bigger. You can see, oh, so these are the after your career, and when you open it, you can see probably list of courses, for example. Then you can see something like blogs, articles, how to build portfolio, do this, trash. You see a lot of other articles. Now, the question is, these articles you are seeing, it is not the front-end engineer that developed it. The only thing he did is that he created a space that whenever there's an article, follow this template. Put the image of the article here, put the topic here, put the date the article was created here, put the button that can take them to the next page, where they will view the main details. But if you check what is happening in the background, this is an example of a request. When you refresh, that's what you don't know in the background, it sends a request to this endpoint, right? API.ecogas/web-list/features.blog. Now, when you get to this endpoint now is a backend. As a matter of fact, it's a Python Django backend, similar to the technology we are trying to learn on this call. Now, this backend will return a response, a 200 OK response. That means the request was successful. And what does the response look like? JSON file. Now, it wouldn't make sense if you as a user comes to our website and this is what I'm showing you as list of blogs to read. Then I expect you to go to next page yourself by creating a page of slug plus the URL. Bad user experience. That will never even happen. You won't even know what to do next. That's where the front-end guys come in. To make sense of this data, represent it in a way that it makes sense to the users. But the person that creates the data that is coming, that they want to convert to something that makes sense to the user, is the back-end engineer. So this is how these people relate. So in the real world industry, please, if you have question time, remember you can always raise your hand, drop a chat or whatever. I will always check it out. Now, in the industry in the software industry, these two people work together. The front-end guys, the back-end guys, they work together to create something interesting that you see out there. Now, there is one little exception that we call a spaghetti full stack. Or there's full stack. Let me go by saying they are full stack. Now, there is spaghetti full stack, there is proper full stack. Now, spaghetti full stack is not completely spaghetti, but there's a way we normally, it's not completely bad, rather. It's spaghetti because there is no clear separation of the front end and the back end. They are common to websites built from CMS, content management systems, or is related technology. Now, this type of technology are not common in enterprise. You will likely not go to a Google or a Microsoft and they are building a software, especially an enterprise-grade software, and they are just writing all their PHP within their HTML to have the website running. That is likely not happening. So this course is expected to teach you a professional path to becoming a software engineer, especially as a backend engineer. So my definition here, backend developers, they handle server-side logic, databases, application functionalities, and technology they use include Python, Node.js, Java, Ruby on Rails, and the rest. Fortunately, in the world of backend, Python is currently one of the most popular and fastest growing language in the industry, especially because of its suitability for AI applications. Now, full stack is simple. Full stack simply means that guy that can do both. That's full stack. Full stack is that guy that can develop the mobile app. If it's a mobile app full stack, for example, he can take a Flutter to build an application that can run on Windows, Mac, iPhones, Android phones, Microsoft phones, all applications, all platforms, that is from the front-end perspective, even on web. And can also build the back-end himself to say, oh, I'm done with the user interface and user experience. Now the server logic, the connection to the databases, which will be happening in the back-end, I can also build that. That's full stack development. Those are the people they refer to as full stack engineers. Now, before now, full stack engineers is always in two categories. Sometimes a full stack mobile app developer, a full stack web developer. So, no, of course, there are a lot of technology used for this. Full stack web means you focus on building web applications, and you can also build the backend for them. So that means you can take a GT Bank internet application, internet banking app, and replicate it from beginning to end all by yourself. A mobile app, full stack engineer can take a mobile app, a Zoom, for example, whatever this current app we're having a meeting on currently, can take it and rebuild it from scratch, end to end. Full stack. There are opportunities in all of the industries. You don't have to do full stack. You may do full stack. It's a good advantage if you have all the knowledge, especially if you want to do a freelancing. If you want to do freelancing, but each of them have their specialized opportunity in the industry. As a front-end, someone that did front-end development, you can get a job as a front-end engineer, mobile app engineer, web developer, and the rest. Back-end engineer can get jobs as API developer, REST API developers, back-end engineers, back-end software engineers, and all this engineering sometimes are a clear path to your cloud computing journey. Person asked me about cloud computing earlier. Now, cloud computing, what's cloud? Majorly, everything we are building, the back end especially that we are building, or the front end, they have to live somewhere. Now, they are currently living on your laptop. Because they are on my laptop, I can run this code I run earlier, Python manage.py, run server, and something is running. And because I'm running it, I can actually go on my browser and access it somewhere. But I can only access it on my laptop and not any other place. Now, if I want to be able to access it in any other place, I need to move that thing to a live server. I don't know if you are getting me. If you are with me, please say I. You can drop it as a chat. You can just say I on mute. But I want to be sure people are with me in this class. I'm not speaking to myself. If you are with me, say I. Or yes, okay. People are dropping. Okay, thank Malone. Where's it there with me? I'm going to wait for no less than 3 responses before I continue. Thanks, Joel. Where's it there with me? Thanks a lot, Meji. Yeah, good. Now let's continue. Yeah. So we have to move it to the web. Now, that moving to the web is cloud. But what is even cloud? Cloud is not even complex. This is our definition of terms. Today is our first class. We're supposed to spend more of it on definition of terms, understanding the industry, and then we move from there to Python crash course, maybe starting tomorrow. And of course, today we talk about the tools you will need and all those things. Now, cloud. Cloud is a journey that started several years ago. At the beginning, it was not cloud. At the beginning, it was just servers. New slide. They were just servers. Now, servers are computers. Let me use a name that is straightforward. Just like your computer and my computer. Now, these computers, they have to live somewhere where it cannot go, it cannot go off, it cannot shut down. It must have access to the internet 24 hours. So imagine someone says, I want to put this thing on the internet, on just this laptop. It must be there 24 hours and must not shut down. That server. The only difference is that there's not a technology that, as far as you have something stored on that particular computer, you can access it from the World Wide Web. That was the technology of the World Wide Web, the initial technology. It's just a technology that allows that I can store something on the computer. I can put that computer anywhere. You can put it in your room, in your toilet. As far as it's connected to the World Wide Web, it has 24 hours supply. you are good. Because the moment that computer shut down or go off, your site or whatever you store on it will not be accessible again. That is what we call downtime. When they say our website is having downtime, we are currently down. The server is down. However, this was not scalable. Imagine the cost of putting 2 computers somewhere, or even 10 computers, and regular power supply all year round, 24 hours, 365 days. The cost is high. All time access to the internet. Plus other, now imagine, now if you, especially for people on Windows, maybe a little exception to people on Mac. Windows, for example, try to use your laptop for like, let's say like 2 weeks without turning it off. Like, just leave it on. Don't turn it off. Leave it there. At the end of, within that 2 weeks, keep using it, of course, be running high applications, playing high-end games, writing code for like 2 to 3 weeks. No hibernation, no sleeping, no shutting down. Before you know it, your laptop will start getting hot. If you are not careful, it will shut down by itself. Eat. Some will even tell you overeat, Phones does it sometimes. This device is, how do they put it again? This device, it is at something, something, something. Please shut down and all those things. Now, you know what is happening? That system is subjected to it because it's generating it for every second it's run. That means if you're going to run a server yourself, you need good cooling system. So that means this laptop has to be running in a place with 24 hours AC for you to actually keep it up and running. Now, this was expensive. Some companies came up with opportunity and say, this is a business opportunity. Let's create a place, rent it, buy like 500 computers. Those computers are called servers. They are like CPUs that can then communicate with a single monitor or software. This is how server looks like. This is how server room looks like, for example. We call them data centers. But this is not a single computer. These are just racks. These are similar to the shoe rack in your house. Shoe racks. And on that shoe racks, we have servers put on them. These are servers looks like. It can be something as small as this. As small as, just thinking about things, as small as this thing. So you can see this is a server now. The R730XD server. Something like this. So a data center as big as this is just a combination of 10,000 of these put on a rack. Right? And we say, okay, if I have it on a rack, today we still have a lot of banks, financial institutions that still run their own in-house server in their headquarters. They store some sensitive information there, and they still run some things on the cloud. But that means you as a company can say, oh, I want to buy my own server, buy 10 server, set it up in my own place. It's an internal server. It's allowed. I still know of several companies in Nigeria that are not even big, that are using internal server, what we want before, where we have our internal servers. Now, data center created it and said, okay, if I now store it here, it's easy for me to tell you, come and buy hosting. This is the genesis of web hosting. Come and buy hosting to host your server. There are types of hosting you can buy. Please take all this theory serious. It might look too theory for now, but whatever I'm trying to give us now is what I call the solid background on the tech space. If you're going to be a software engineer, reality is that there are some terminologies that you have to know. There are some differences you have to know. So when someone comes to you and say, oh, I actually hosted this thing on shared web hosting before. Can I host my Django on shared web hosting? And you don't even know why you want to tell them no, they can't. Or you don't recommend it. Maybe some people would in online, of course, there are some articles that will start telling you you have a way to host Django on a shared hosting. But I believe those articles are scam, like maybe not an enterprise grade level. I've never tried to do that, and I will never try to do that anyway. But you need to know what's even shared hosting. If you don't know what is shared hosting, how is it different from AWS? What's the difference between buying a shared hosting from Google versus buying a cloud, an EC2 from AWS? Then you are not yet there. And part of software engineering journey sometimes is understanding when you are done with this solution, at least understanding basic hosting techniques. It may not be your work to optimize the server, to make sure server runs fast, to create server strategies and all those complexity. But it's still your work to ensure that, of course, you want to test this thing sometimes, or you might even be a personal project. Especially if you're a full stack engineer. You want to host your, today I host my solutions myself. I've spent most of the last 24 hours trying to do some troubleshooting on AWS and the rest. So that's why this background is like a solid background. If you want to take a note, you can take a note. But I'm also going to be sharing some content with us during the week, where of course we're going to be onboarding everyone on this call, now LMS, most likely before the end of the week. We have some optimization to do, where we're also going to be having access to some self-paced content that you can run with, especially for backend that we are starting. And for people on full stack, before you jump on your mobile app or your front end tool, you would have access to our self-paced courses together with these video courses. So during the week, we expect you to check out the resources, check out self-paced courses, do some assessment, your task, and the rest. And weekend, we have a lot of questions. Then, of course, we also take the syllabus alongside as we move on. Now, going back to my concept of understanding hosting. So you wouldn't be a novice of hosting after this talk. That's my goal. Now, imagine I've told you we just have single computers. People buy it and store it, and those computers look like this. What do I have here? This is what I'm using. Now, they look like this. And this is what they call data centers. That's the beginning of data centers. Now, people come and buy space, just like you want to rent an apartment in an estate. This is like estate of computers now. The advantage is that these people will be the one to make sure light does not shut down here 24 hours. They are the one that will make sure they have efficient cooling system. They are the one that will make sure they have what's it called? They have fire smoke detector. Because you can't put this lot of computers in one room. Trust me, one day everything can just burn and everything scatter. You need something to detect smoke and all those things. They are the one that does all those. You don't have to bother. The computer software has expired. It needs upgrade. The processor just got bad. It's not your headache. Data center handles that headache. Now, people now go and buy service. Different services that are available. And these services are still available today. Only that their popularity is reducing day by day. We have what we call dedicated servers. We have what we call VPS, virtual private servers. Or what else they call them again? But VPS. We have what we call shared hosting. And we then have cloud later on. Cloud is not even here yet. Cloud will come in later. Now, of course, you can also build all these on cloud. So that's why I say cloud will come in later. But now, how does this work? Dedicated server means, now imagine dedicated server from the word dedicated, it's even descriptive. Dedicated means this is one computer now, a CPU. In this data center, we have 1,000 CPU. I want to buy an entire computer in that data center. In that data center, I'm the owner of that computer. The only difference is that I'm keeping it in your space. I can ask you shut down my computer. I can ask you restart my computer. I can ask you upgrade the software on my computer. I can ask you I don't need Windows again. Uninstall Windows and put Linux. As a matter of fact, you can give me interface to do it myself, but I want to do it. That is dedicated server. From the word dedicated, like dedicated computer is my computer. Now, dedicated computer have two types, or not, maybe not type, managed servers, or generally. I think it shouldn't be like category. Let's make it a subcategory. I know this is getting complex, but they're like definition of terms. There are things you can read more about. Managed servers. I've not started backend yet. I'm still on theory of software engineering. And on managed servers. Managed servers and unmanaged servers. Yeah. Now, managed server simply means I'm not just buying the space, right? I also want someone that will be managing the space for me. So indirectly, I'm buying a managed dedicated server from, let's say, a GoDaddy. What it means is that security patches, upgrades, and everything, GoDaddy we manage it. My own is just to host. On managed servers means GoDaddy will just send the server to me. If the security requires upgrade, I will have to run it myself. If it's shut down, I won't go and shout on GoDaddy yet. As far as it's not like hardware problem, GoDaddy only provide the hardware. They don't care what you do with your software on managed servers. So except your company has a lot of experienced cloud engineers or server engineers, they will likely not buy on managed. They will likely go for managed. Now, under this, we then have, it can be dedicated servers, can be dedicated managed or dedicated or managed. Virtual private server. How many of us know about concept of partitioning on a laptop? You've done something like partitioning before. Someone has mentioned partitioning to you before. How many people on this call? Partitioning, someone has mentioned anything like partitioning to you before in the past? You've heard about it before. If you have, let me know. As you see on your laptop, you can run Linux, you can run Windows. Okay, no one. Now, on your laptop, there's a way you can actually partition your laptop. You can install both Windows and Linux. It's the same laptop. But when you are starting up your laptop, you can then decide, I want to go into the Linux OS. I want to go into the Windows OS. But if that laptop battery is bad, both OS will not be available because it's the same laptop. If that laptop CPU shut down and got damaged, even if you have 10 partitions, all the 10 partitions will not be accessible. However, what I store on partition A can never be available to partition B because they are like breaking my laptop into multiple sub-laptops. That is concept of virtual private server. They will take a dedicated server in the data center and break it into pieces. Maybe 3 to 4 pieces, not usually much pieces. But those pieces are individual, independent pieces. You can run, you can make decisions like it's a dedicated server, but you can't ask them to shut down, for example. But you can say, okay, uninstall Linux, put Windows. You can do all those ones because it's virtual private servers. And they are much cheaper. The problem is the price of these things. That's why if you check dedicated servers, buy dedicated servers online. It's always like per year, you might be paying like about 2 million naira per month. Google is done again. Let's see something like buy dedicated servers. Let's just see, let's do Namecheap, for example. And let's see pricing. Now, this monthly price for Namecheap. Dedicated server means you are buying the entire server. I can see they have different configuration. If you want a Core 4 laptop, a Core 4 server with 8 GB RAM, 240 GB hard disk or SS, that's the SSD, and this is the bandwidth. I can enter it per month. You are paying $47 per month, about 60,000 or so, or 70,000. No, $60. This is just first payment. And the rest. The more the space, you can see the more the RAM, the more the hard disk, the higher the price per month. So imagine someone doing 238 per month. At today's rate, 238 times about 1.6 would mean I'm doing like 380,000 per month. If I do this times 12, you know I would have spent 4.5 million in buying this server. So if I'm a small website, I want to just host a small application, maybe my small Django or small whatever, and I'm buying a dedicated server, and I have to pay 4.5 million, and it is still not as reliable as cloud. I'm coming there. Now, that's dedicated server. Virtual private server is this one server like this, now broken into 5 servers, 5 sub-servers. That will be cheaper. If I go to their hosting and I look for VPS hosting, virtual private servers, you control and flexibility when your business needs it, but you can see, if I go to the monthly price, I can see I only get to pay like $28 per month. Full root access, you can see you have the root access. That means You're also an admin on your own operating on your virtual private server. You can select the operation OS you want to run. I want Windows, you can do a lot of things because you have complete control. It's like you have a dedicated server control, but you know you are not the only person using that server. Now, the last one is the shared hosting. Now, shared hosting it can be dedicated, it can be private server that was used, it can be anything. It simply means, imagine your laptop today, the way you create folders. You create 5 folders. One folder is for Femi. The second folder is for Adijat. The third folder is for Joel. The next folder is for Relua and the rest. Now, you have 5 folders. Now imagine there is a software that can control that if you are logged in as a user, as this particular user, you can, no, let me use Google Drive. Perfect example. On Google Drive, when you create, maybe many of us might not know Google Drive, but similar to how your laptop works, if you don't know Google Drive, you can create 5 folders and share who have access to each folder. That's shared hosting. That your website, you store it on a folder on my laptop. 500 people can store on my laptop. 1 million people can store. It's not your business. As a matter of fact, they will not give you that information. You can see they're not giving you information on the number of people that are using that where this thing is hosted. Their business is you want to come and buy a folder. And this will have a lot of limitations. Sometimes they will not list it here. If you overuse it, they will block you. You have to raise tickets before they will unblock you. You will get to a limit and they will say your laptop has grown. Many of them even always have limit. They will tell you from beginning to say you cannot, these are things you cannot do. Yeah, there will be a lot of features like this. Disk space. You cannot store anything more than 20 gigabytes. 5. You cannot have more than 300,000 files. The moment you get to 300,001 files, they will block you. You need to raise the ticket. Why? Because you are not the only person using that laptop, that server. The plan, if it's going to be profitable for this, they've calculated it. If it's going to pay me, I'm going to collect like $5 per month from you. And we have to make sure I have used 1,000 people on this server. That's the only way it can pay me. And those if this server can only handle 3 million files, and we have to divide 3 million by 1,000 users. That's why all these limitations are happening. You won't see this type of limitation in a dedicated server or VPS. It's not a business. It's not their business. But all of you are sharing the same server. That's shared hosting. Now, shared hosting, you don't have root permission. And that's why you cannot host complex applications like Django and the rest on the shared hosting, because they require root access sometimes, most times. But you can still host your WordPress, your Joomla, your simple PHP and HTML5. You can host them on the shared hosting. Now, how did we then get to cloud? When you buy all these things I've mentioned, remember it's still a single computer in this place, in the data center. The question someone should be asking is, what happened if this place we are showing got burnt? What happened if there is fire and they shut down the entire data center? What happened if that computer shut down? This server here. What happens if I want to do a system upgrade and something goes wrong? Those are core questions. Those questions became so popular that companies like AWS, Amazon, Microsoft, IBM, and Google, those are the 4 cloud giants. We're going to be using some of them before we finish, just as part of the bonus sections, hosting your Django app. Google Cloud, Azure, owned by Microsoft, AWS, owned by Amazon, IBM, and maybe some other smaller ones, DigitalOcean, all the small ones that are built on other technology and the rest. Now, what did these people do? Nothing much. They just said, okay, instead of having a single data center like this, how about I have money? How about I have something like this in 5 locations of the world or 20 locations in the world? Right? And those 20 locations, one can be in Europe, one in Africa, one in Dubai, and And we have a way to connect all the servers together so that they can work as a single global server. That's how cloud started. So if a data center in Africa shut down, data center in Dubai will still be working. But there's a software that allows me to replicate my customer software in split seconds. I can quickly move it from a Europe data center to a Nigerian data center. Or if their customer is in Nigeria, they can decide to say, okay, store my data in the Nigerian data center, except Nigerian data center is unavailable, scale it and put it in a US data center. Another advantage, this server is 1 terabyte. When you are done with your 1 terabyte, you are stopped. On the cloud, you have unlimited terabytes because these are interconnected 1,000 terabytes of servers. So if yours is exhausted, you can keep expanding. You can host 1 million gigabytes and you only pay for what you use. It's like a shared hosting, but in a more reasonable way. You now have the access. It's like a technology that then say like a VPS on a cloud. And different hosting company or cloud company like AWS started the concept of cloud. Interconnected servers that are singly connected globally. And they handle maintenance. And today, what we now have today is that each of them now started building product to attract users. It's a contest. Azure will tell you there's a beanstalk that you can use to host your Django application. And the rest. So this is how we arrive at cloud. Now, software engineers always know, of course, along the line, you can actually also start a career in cloud. Because cloud engineer simply means that guy in charge of that knows AWS so well, and I can be done with my API, and we give to him to say, guy, it's your work, go and host it. That's the work of cloud engineers. They are the ones that write stuff like what we call CI/CD. CI/CD are things that automatically deploy your solutions. So you can say I have a lot of, no, these are EB extensions. Let me look for one of my CI/CDs. GitHub. Maybe one I'm not using at the moment. Now, these are examples of CI/CDs, right? I can write something that looks like this that may not make sense to you as a software engineer, but I can write stuff like this as DevOps engineer or whatever I am, and it will go to AWS, and my site will be available on the World Wide Web. That's cloud. So software engineers cloud engineers that have strong background in software, they are always more of a big cash because, of course, in the first place, you are trying to make a software work in the cloud or, work with some data set in the cloud. So having a strong background of software would be a great advantage, and especially backend, because backend engineer deals with a lot of things at the same time. Your database will be there. You need to have your database. You need to have your database. So these are Django databases now. These are connected to Django's and the rest. So reality is that you need to know all of these things. And these are like other career paths you can consider. You can be a full stack engineer that also know how to host your solution. But just to mention, it's optional spending your time on learning to host. If you want to, good, cloud good, DevOps good, there are additional skills that would make you more attractive. But there are people that's their own work. That's their own job. That's their own specialization. Hosting, ensuring it's scalable, and the rest. But it's actually a good cash if you know it. Today, I do a lot of these things as a full stack. And of course, it's advantage that I can build my own solution. I can build my front end, build my back end, host it on AWS or Azure. And it's live to everyone. So I can have issues, fix it myself. And if you check my download folder, this is what I've been up to majorly in the last 24 hours. You can see I've seen a lot of, been working on a lot of bundles. All these are AWS bundle file to troubleshoot errors and the rest. So this is what a cloud engineer is supposed to be doing. But if you have the idea, it's easier for you to jump on things yourself and get them fixed. Now, with that being said, that's a background of how these three industries interact. Now, in none of this particular course is focusing on the man in red or the man in pink or orange. Don't mind me, I'm very poor with color. Now, so we have Django. Django is a Python framework. Python is one of the fastest growing and the most popular language we have out there today, especially because of the, how do we call it now? Because of the AI noise. Let me put the word noise. It's so noisy today that everybody is using AI. It's like one of the biggest opportunities today. And AI applications are mostly, of course, built in Python. And when we want to host AI applications too, we build the REST API backend. That's one of the reasons why backend engineering is also very, very attractive. You are not just building backend for software sometimes. ChatGPT will not be possible without a backend engineer. So there has to be someone that will build a microservice, an API endpoint that other systems can interact with. So 500 systems can interact with a single backend. Facebook has a single backend. Of course, can be broken down into subcomponents, like the one powering users, maybe they call them microservice, but it's a single backend. And that is why if you post something on Facebook web, or someone message you on Facebook web, and you go to Facebook mobile, you will see the message immediately. It's not like wait 24 hours before the message appears, because it's the same backend. It's only different user interface communicating with the same backend. So Django is one of the, it's the most popular or the most advanced Python framework for building web applications. Now, Django can be used to build full stack software. Let me say that too. At the end of this course, you will also be able to take Django and build a full stack software. That is, you don't need any, you build the interface yourself. You can build the interface if you know HTML or CSS, just put it in. Although not a common use case, Django is majorly for backend. At the beginning, no, it's an evolution. People use it for full stack. At some point, new dispensation is majorly for building REST APIs, backend APIs. Now, it's just based on Python syntax. These are one of the reasons why. The other ones, you can add about Flask and the rest, used to build quick applications and the rest. Now, Django is it encourages fast, what we call fast development, which is the latest trend in the software industry. Check all the technologies that are making waves today. The only reason they're able to make waves is that all of them are they're actually competing on speed. Let me put it that way. Before now, if you want to build mobile app, you need to go and learn one language to build Android. You learn another language to build mobile app for iOS. You will learn another language to build a desktop app. You have to learn like 5 things before you can build. If you're a CEO that owns a company, you need to employ people that will write all those different languages before they can build something reasonable for you. React Native came and said, no, I'm a React Native. I can actually, with little cough, can actually build a cross-platform. Google came and said, no, Flutter. With Flutter, with speed, reusable widgets, you can actually come up with a cross-platform application that when you are done, it can run on iOS, it can run on mobile, it can run on desktop, it can run on web. It means if I'm a startup trying to build today, I'd rather build on Flutter. Because when I'm done, I have a software that can run everywhere. And that started gaining momentum. For people that are joining the mobile app course, or people that will still be joining on this course that have enrolled for that, of course, that will be coming after the backend. They'll be using Flutter, for example, because that's one of the fast-growing technology. And why? Fast development. Same way in the world of backend, Django is that fast development guy. And that's why companies are running towards it. And aside the fact that it's fast, it's still very developed and secured. It already comes by default. It has ways of preventing common security vulnerabilities. Before now, headache of backend engineers will include stuff like SQL injection. Django naturally solves this. Just follow the practice. And you are already like 80% leg forward into securing your application. If you're a company, would you rather pick a backend stack that when you are done building, you are just at 1% of your security. You now need to start the process of, now let's start, how do we secure our application the next day? I was reading on Twitter yesterday, and then I saw Bybit was, the app Bybit of about $1.7 billion or so. So that's the crypto world, Bitcoin world, though, no, blockchain world. But that's a practical example. There's a time they hacked Facebook and a lot of other things. So security is the nightmare of every tech company, of every tech solution, of every bank that owns that software. So if I have a backend that technology that is more secure, what will stop me from using it? Django. That's how it gets its popularity. Scalable. Django can be used to build small applications or very large applications. What I show on my screen, this is an example of a large application actually. Is like, you can see, for example, one thing that stands out is we have a lot of moving parts, a lot of sub-applications. You can see all these as sub-applications. So that means if what I need is just a single application that will do one thing, Django can do it. If what I need is something scalable, I'm building the next Microsoft Dynamics, I'm building the next Zoom, I'm building the next Facebook, I'm building the next Twitter, Django got you covered. That's what it means. Then batteries included. One of the things that make Python, interesting is because they have rich libraries. And batteries are more or less like, I'm starting to build now. I don't need to start thinking about, I want to write my authentication logic from scratch. As a matter of fact, I will not do that. Because when you do that, you are just building vulnerability. You will roll out and they will hack your login in less than 2 days before you know it. Because some people have sit somewhere working on troubleshooting how to do these things for several years. So Django already has a lot of built-in authentication approach you can use. And you're already confident, you are already like 80% security forward. And that's the world of software. The world of software is not about, you're a front-end engineer, for example, it's not about just using that to write something from scratch. I met a software engineer recently, and then, of course, he said he writes Python. And he likes writing his software from scratch. He doesn't use any framework. I just laughed at him and told him the real truth. It was the bitter truth. He wasn't happy, but it was the bitter truth. I told him, guy, you are not yet a software engineer. I'm sorry. You want to know, you want to prove me wrong? Try to apply to Microsoft, apply to Google, apply to a real company that knows how software works. Go to interview and see if they will consider you. They will not. You might think you write something that's working, but it only takes another 30 seconds to hack it. Because frameworks are open source most time, and they are written by, they've had like thousands of contributors that have been building these things for several years, fixing vulnerabilities in new versions. So software companies expect you to use some of these things. Admin panel, you already have an admin panel you can spin off. If you want to use it for testing, or even use it for live. So there are already a lot of, you have a better way to define your databases. So it means I don't need to give a headache about how do I create all these tables and their columns. I don't need those headaches. All I need to do in Django is to come to an application, go to models.py and create the logic for my code. So it's what I create here, for example. When I run something, whenever I run it, it's that thing that will go ahead to create the database table and create the columns. Batteries, ORM. Objects to relational mapping. These are objects. This is what we mean by object. These are Python objects. We learned that in Python crash course before we start. So the next two classes is going to be a little boring. I like to do it. It's boring, but I will do it. I'll do it because I'm going to be telling you introduction to Python crash course. It's not going to be boring when I mean in terms of boring. What I mean is that you're going to have to lay your hands on understanding code. It's a one-time thing. If you master, it's going to make your journey easier. You will see courses that will not start with Python crash course. You just go straight into Django. The idea is that you will be learning it as we are doing it. But your learning part is going to be difficult if you follow that approach. If you see what I write here now, you don't know what it means in Python. What is description? But imagine you already know description means a variable. So it means this guy is just creating something and storing it as a variable here. you will know what that means. If I do class, you don't know what a class means. You're already confused. You don't know what a DEF save means, a function within a class. You're already confused. You see where I use if. You don't know what is if doing. Why is it using if? Or why is it putting semicolon? If you remove the semicolon, what will happen? You don't know. You will be learning Django without knowing the background. At the end, this code now will start giving me error. You will struggle with it for 1 month, not knowing what to fix, because you don't know Python crash. If you know Python and you check it, you would easily come to a conclusion that the fact that I don't have a colon here is the reason why this particular logic will not work. Because a Python conditional logic is expected to have this column, and this indentation is important. Now, you might think you are working exactly what I'm working. Now, I was actually watching a tutorial online, maybe on Google, and I'm actually doing exactly what they've done. So how come my own is throwing error? Just because you did it like this. This will throw error. You can see it's already underlying it. Expected indented block. So imagine just a space is giving me error. What if I know about it and I just do a nest? Error result. So in reality, what we're going to be learning starting tomorrow is what are the Python syntax? How does it work? For people that we have time during the week, please, I want you to start strong with me. I want you to actually also read out some things on Crash. With that being said, I would soon go into the tools we need before we enter this class. So Django, that's it. We're going to be working with a lot of tools for this course. Python, we're going to just be doing Python. Everything we want to do is Python. Django is Python. So we are not downloading Django separately. We see how to get there. But what you need for now is download Python. On your laptop, you go to Python page. I will advise you not to download the latest version for now. Why? Sometimes the other libraries like Django and Co, they might not be compatible yet with they might not have released latest version that's compatible with latest version of Python yet. Or sometimes they might have changed some things that will still give you some issue. So to be on safe side, we have Python 3.13. I think this is a new release. 3.14 is even out, pre-release. You can see the release nearly every time. So let's go for something around maybe a 3.10 or 3.11. These are bug fix, 3.12. It's in bug fix, so they still have a lot of bugs they are fixing. So let's do a 3.9. End of life. This has reached end of life. So let's do a 3.10 or 3.9. You can do anyone you want. But let's do 3.10. So you just need to come here and download what you want. A 3.10.16 or 3.9, can pick any one of these. These were December, these were still in the last 3 months. So I want you to pick something in the last 3 months, not far off. Maybe the highest I want you to pick is 3.9.21 or 3.9. And to click, you just click on download. Click on it, you see a download button, depending on your laptop. For Windows, I want to get the Windows endpoint. Downloads is Python/downloads. I don't want latest release. So Windows. Do we have people on Mac here? Do we have anyone on Mac? Okay, good. Yeah, download latest version. Maybe you can continue with that for now. One of the latest version, sometimes you can see the actually latest version, for example, is 3.13. It's currently in bug fix status. There might still be some bug. So if you're an experienced person, sometimes there's a way you can easily fix your bug. But as someone that is learning, you don't want to be spending your time fixing bugs or trying to. So I like to actually pick something that's maybe it's within the last 3 months release, and I'm sure it will be stable to an extent. So that's why I love a 3.9, a 3.10. But yes, you can still download 3.10. It will downgrade your Python to 3.9. So all you need to do is to download 3.10 and reinstall it again. To just reinstall it over what you have. And that would bring down the version. So this is if you're on Mac, please let me know. I'm trying to get Windows instruction. If you're on Mac, no difference, you just need to click on Mac OS. And if you're on Mac, you then have to decide, are you on Silicon, Apple Silicon, or Apple Intel? If you're on Apple Silicon, like the M3s and Co, you you download the Silicon version. If you're on Mac, if you're on Intel, you download the Intel version. But if you're on Mac, please, you can let me know so I can guide you on specific things to install. And yes, I'm going to be, I'm on Mac though, but I'm going to be ensuring that whatever I'm teaching is linking back to how you want to do it on Windows. So I'm very careful. So if you're unable to do anything on Windows, please let me know at any point in time. So I'm download. This is 3 points. This is the download page. I want to go to the specific version and give you what to download. 3.10, where is latest 3.10? And note, you cannot be used on Windows 7 or earlier. So if you're also on Windows, you want to check that out. Python 3.10. Okay, what's the latest we have here? 3.9.16. December 6. No, this is not this. How come 3.9 is December 6, 2022? So let's look for something recently. I want for something last 3 months. Stable, yeah. And make sure you're downloading from stable releases. Don't go to pre-releases. These ones are still in testing. Python themselves have not even released. So they are still testing. So you have to download anything from here. So let's look for something latest 3. This latest 3.10 if you want 3.10. But let's go for latest 3.9, which is 3.9.21. And this is it. I'll click. No. No installer for this. If you're on Windows, it should even bring the download button for you automatically. When I was in Windows, I used to see all those things. It's going to be just be down here. Okay. Why am I stressing myself? Faster approach. Faster, faster, faster. Oh, Google was done. Is it back? So that's the first thing you would install. And that's what we're going to start with. Every other thing, we're going to use them along the line. Google Colab, you don't need to download. It's just a place you can quickly run your code. You don't even need to, you won't be needing it in the long run as a backend engineer. It's just to test run. We're going to be using it for a Python crash, just like a quick one. I think I can remove it from the tool you are using majorly. Git is what you're going to be using to push your code to GitHub to save whatever you're working on to somewhere where you can always access later on. Postman, you'll be using it to test your software. For a start, we won't install this. We only install this tool for now. And maybe Git. But let me get the link to everything. Download Git. Download VS Code. Please, VS Code is different from Visual Studio. So we have Visual Studio, we have VS Code. So make sure you are downloading Visual Studio Code. VS Code is like a minified version of Visual Studio. So you're able to, it's actually like a code editor. Great for your code.
Tech Oga, what if we have Android Studio?
I'll still recommend you, it's just an editor though. So you can still use that, but no. You can still use that, but to minimize complexity, VS Code is just like less than 20 megabytes. So it's just like small, it's like just like a notepad. It's a notepad. So I would still recommend you download VS Code actually. It's going to make your life easier. So this is VS Code.
Please, bring out what we are going to download again. Let me snap them.
Okay. I'll still share this slide with us though.
Okay.
I'll share the slide. And I want to share the links to everything we are downloading with us too. I will share with us on the group too later on. Okay. So I guess I don't know what's from my Google. I will share this link. So when you see this link from me, watch out for this on the group. No, PyCharm is different from yeah, you can use PyCharm, but maybe for all of us to work on the same, it's like an editor too. But for all of us to work at the same pace, I would recommend we all work with VS Code. Just so that we're able to troubleshoot easier, and the rest. And it's like very simple. Maybe I'm just a lover of VS Code. But you can, if you're already in love with PyCharm, good, it will work. You only need an editor. Why I'm asking you to download is that you will need an editor to open your code. This is an example of a Django code. This is what will be created by the time you launch Django. And when you create this, you need somewhere you can open your code at the same time. You're not going to be opening them one after the other, like a Microsoft Word opening or a Notepad. You need a particular editor that can open your code. You can view your code. Beyond that, you can actually download specific packages that will help you show when there is error. For example, if I have an error now, you can see it's underlined. So it's easier for me to quickly know this is where my error is. I can also run terminal here. Not just one terminal, I can run multiple terminals. If I want to run my Git, whatever, I can create as many terminals as possible. I can also debug console. So VS Code is used for a lot of things. I also use it for mobile app. You can also run it. You can even run directly. Run Python 5, want to use it. It has a lot of advantage. So that's why I prefer VS Code. It's not important. It's not compulsory. .com. Oh, I'm using my internet for quite going. So what's happening with Google? I know it's Google. So it's called Visual Studio Code. This is the link, but you should make sure, yeah, to bring Windows, Mac, just download your version. It's always like maybe some megabytes. It's always some megabytes. So let me share this. I'll share this on the WhatsApp link later too. WhatsApp group. Then aside VS Code, what else do you need? We need bing.com. Download Git. Maybe just keep that on the laptop for now. We're going to need that. It's just download Git. So when you download, just double click on them to install and follow the instruction. When you are installing Python, remember to add to part. You will see a place that we ask you to tick add to part. Please tick it so that you have it installed. So you just, this is the page to download Windows Git. Click on your operating system. Drop in the meeting chat. Then what else? Bing.com. Postman. Download Postman. This is where you download Postman. It will bring for Windows if you're on Windows. And if you're on Mac, it will bring this and you can download the one you want for your Mac. This is Postman. And lastly is Python. This is a page to download. Windows. Or maybe you can still run with the previous latest one for now, but we need to check is Django compatible with Python. You said you have 3.13, right?
Yes.
Okay. Someone joined us, right? You need to mute. So let's say okay, so we want to be sure we have Django 5.1, Django latest version. No, I don't like Bing. They are showing 2022 news as latest. So let's go to Django page itself, downloads. And I want to see if I can see version history. Release versions, latest release. Oh. So what we have now is we don't have, it's not compatible yet. So you could see what I'm talking about. So we need to do a Python 3.9 or 3.10. Yeah. So I'll share the link to that with us too. Yeah, download the rest for the rest, everything except Python. Download the latest for everything except Python. So Python, you download 3.9 version or 3.10 on your Windows. I will share this link on the platform. So let's download all this link against tomorrow. I would like to take questions, clarity questions, clarifications, and the rest before we draw the curtain for today. Any question from anyone? Clarity? Yeah, so great to have you join. Tomorrow, we install Python. For people that wouldn't have installed it yet, but I will advise to try to install it beforehand. Then we write our first Python code tomorrow on our journey to becoming the backend engineer. If anything is unclear, I'm on the accountability group. Please feel free to raise it, and I'll be there to respond to your questions. Thanks for joining today, and have a wonderful Saturday ahead. Bye for now.
Hey, shut up. Hello, Mr. Tekog, are you done?
Yes, we are done for today.
I thought there is room for question now.
Yeah, we've been asking any question.
I did not hear, sorry.
Okay,
Like,
please go ahead.
I want to ask, can we have a kind of syllabus we will follow? And there is this thing I don't want to repeat itself. In our last class, the video was just uploaded. There was no topic. Like if you
Oh,
have, yes, our last Flutter class, the front end.
are you picking from the Google Sheets or from where?
Google Sheets, YouTube, there was no topic.
Oh,
It
wow.
was-
So I'll check that out.
So even
Yeah.
if you're looking for a particular, like probably you've forgotten a particular something, you can just always go there. This how to write, how to get information from API. You can always click on that video. Not like you will need to watch the whole 15 videos before you know where you are going. Like I said, can we have a kind of syllabus we are following? So we know. Eh?
Go ahead. Go ahead, please.
The Django too, is it part of Python? Or it's another programming language on its own?
So Django is a Python framework. So it's Python. It's like a framework for Python. Just like Flutter is a framework for that.
Okay. Okay.
Yeah.
That means you can use the Django to build an app.
Yeah, Django is what we used to build a mobile, what we used to be a backend. Every backend app, you're going to be using Django.
Okay.
But you can also use it to even build a full stack with interface if you want to. But that's not its primary use case.
Okay. All right. Thank
So
you.
you're going to be learning that. There's a syllabus. I don't know. You may not have it yet, but I will ensure they share this. But today we have a syllabus for this. There's a detailed syllabus on what you're going to be completing. Aside even sharing, like I mentioned, during this week, we all be onboarded on our LMS. So on our LMS, you'll be able to see the different recordings. Just like you mentioned, I think it's something we're also working on too, but I'm even surprised we don't have that already on the Excel sheet. But for this cohort, aside this weekend recording that we are just starting with Excel, hopefully by this time next week, we should already have be on our LMS where you can then access link to recordings you get, and then few other things easily for your consumption. So, but yes, we make sure that's done.
Sorry, you made mention of Excel. Are we still using Excel in this course?
No, what I mean is that we had those listed on Google Sheet Excel also. The
Okay,
previous
okay.
record.
Okay.
Like that's where we structure the class recordings to say class 1, class 2, class 3, class 4, class 5. You get the link to each of them. So
Yes,
that way
I understand that class 1, class 2. It's stated there on Excel. But there should be a topic guiding
yeah, that's
it.
why I said that. Yeah, I agree with you. So for other ones, we normally have a topic. I don't know why maybe the programs manager in charge of that, maybe he missed that.
Okay.
Normally it's supposed to be like class 1, the date the class ends, and the title of what you discuss in the class.
Exactly.
So maybe on introduction to software, class 2,
Exactly.
Django, that's what it's supposed to be. But what I'm not saying is that for this cohort, for this particular backend cohort, we'll likely not even be using Google Sheet to the end. We're going to be migrating to our LMS where you can see a more detailed title and all those things. But yeah, but we've taken that feedback. We make sure that doesn't happen for this.
All right. Thank you.
We'll get the slides and everything. So yeah. All right. In the case of no other question, Or any other question again? Maybe you just had a thought through. Okay. In the case of no other question, thanks for joining. Have a wonderful day ahead. Bye for now.